In this episode of Finno-Ugric Machining, we are going on with this cycloid drive. We are going to level some pins in the milling machine, and then we are going to broach a keyway to this eccentric bushing. Okay, let's start with the pin leveling. Well, I have clamped now this pin system onto my table. Well, I assume that the table is level and I also assume that my cutter is level. So I also have found out which of these pins is the highest, and it's this one here. So I will touch first that pin and then I progress with 0.1 millimeter cuts, really tiny cuts. And well, at some point we are touching every pin. After that I start measuring. I think it's this pin which is 18.5 millimeters high. So our goal is exactly 18 millimeters. So, well, that's what we are going to do for the next half an hour. Well, in the video it will not be half an hour. So now all the pins are level, but they are too high at the moment. So our goal here is 18 millimeters exactly. So let's measure how high we are at the moment. Let's see now. Push it quite hard against these two pins and then, well, I would say about 48 hundredths too much. I should get a vaccination against misreading this instrument. The correct value here is 18.43. So it's well, it's 18.48 maybe, 47 maybe. So this is the z-axis, the height of the table. So, and the backslash is now this way. So I'm going to make it higher. So now we are at 0 here. So if I want to take 45 hundredths of a millimeter, so that would be 1/10, 0.2, 0.3, and 0.4 would be, but, well, 45. Well, I would say 45 would be actually too much. I would take only 40, so let's do this again. So the table is at the moment like 4/10 of too low. So 1, 2, 3, and then 4 here. So now we are peeling off when we are reaching 0 here. So then we are like we have done 0.4 millimeters, but since we probably actually I was reading this wrong way around. The correct depth is 43. So no more than that. Then here is a locking mechanism which you don't see at the moment. I can lock the dial, so now it stays in place. So I will be taking 0.4 millimeters. And let me show again this thing, what I did. It's so easy to read this wrong. Hopefully this focuses, maybe. So if you look, so 45 is there, this is 40, so it's actually 43. And this goes backwards. And well, I always make mistakes with a depth mic because it's so different. So let's see what is the current height of these pins. Well, it should be quite precisely something like 18.0, maybe 3. That would be the best. Let me find my optivisor here. Okay, now also I can see this, not only you. So let's see now. There you are. Well, it's 500s over. This is telling that story at the moment. No, under. No. Depends. There is some, maybe some chips down there. Yeah. So here. Oh yeah. Well, it looks like we are quite exactly. Well, it's 18.4 or 5 at this point. This one you cannot see. I will measure it here as well. Well, here is the same. So, I think we are there. Okay, this piece of material is tool steel. Well, I think it's in hard state. And but it doesn't matter. I can work with this. These Cermet inserts eat it for breakfast, really. So they should. We will see. Well, the thing is that I need to. This is 6 millimeters wide, and the keyway will be 5. So the blade needs to be 5 millimeters wide. And if you observe carefully, so this is tilted this way, just a little bit. So now when I peel off here, when I reach the back side here, after that I will take 0.5 millimeter. It was flexing from that end so much that it went around. So, well, now I have a support here under. Okay, now that I have milled the sides, they became quite good actually. So now the next operation, this is now the 5 millimeter wide side. I will now, well it's a little bit over, not a lot, but 200 or something like that. But anyway, now this workpiece is now tilted this way, a little bit, very slightly. And I will, now when I mill this, this area here, it will be deeper at this end and shallower at this end. This means that the blade, the final blade will be wider at this end and narrower at this end. It also creates the needed relief here on the underside. Okay, I skipped a few steps of preparing this tool. Well, of course I have stoned it. It's very sharp at this edge here. And then I also have a little bit started so that I know, now I really know that it cuts really nicely. I have been cutting here like 0.25 millimeter cuts. It goes really smoothly in, like that. Almost no resistance. And this is like really cutting. So as soon as this, okay, now we have real cut. Okay, so as soon as this rounded part in the bottom disappears, now I'm taking 0.2 millimeters and it goes like that. Let's take another, yeah. I think it's, well, let's take 0.2 more and then that's the last one. Okay, now it's cutting, really. All the way, yeah. Okay. Oh yeah, now there is this key way in the eccentric bushing. Well, it didn't go as I was planning it to go in the lathe. It somewhat worked, but the bearing material is so slippery and somewhat hard at the same time. So the blade just, well, it bent. Not bent, but it was not cutting. So, well, okay. But a file that made the trick at the end. And now it's there on the table, running, and I'm quite satisfied with this one. Well, in the next episode of Finno-Ugric machining, we will be doing making the cap on top of this pancake. And well, it has some work holding issues because it's rather thin, only 10 millimeters thick, and it's there shouldn't be any center hole in it. I'm not sure how to do this at the moment, but I'm sure I will find it out. So, well, till then, bye!